Hi everyone, welcome to this video where we're going to try some LOD score problems. So here's the first pedigree that we're given, and we need to decide if this is a phase known or a phase unknown. Because that will tell us what equation we need to use. Now, this is actually going to be a phase known pedigree because we can see that all the family members are alive, and from generation 1 to 2, the couple had one child, and then that one child had a lot of kids. So it's clear to see that this is a phase known. So we're going to use this equation. Now we see something called the R and the N here. And the R and the N is basically what you're trying to find, whatever is recombinant or non-recombinant. And recombinant means that there's crossover between the disease gene and the marker, but non-recombinant means that there's no crossover. And ultimately, we're trying to answer the question, is the disease gene linked to the marker? And if it is, how far? And to answer that question, we want to get a LOD score that's greater than or equal to 3. So using this equation, we're going to plug in these values for theta to solve for z, which is our LOD score. So now I'm going to show you guys how to set everything up. First, we need to set the phase. So because this person is not shaded in, that means that they don't have the disorder. So we're going to write a little d, which is our disease gene, and the number 1, and then a little d, 2. So I'm going to write over here, a little d means no disorder. DD means no disorder. 2 capital D's mean that you do have the disorder. And if you have a capital D, lowercase d, you still have it, and you're shaded in because it's a dominant disease. So now let's go to the mom who does have it because she's shaded in. So she's going to be a big D, 3, and a big D, 3. So now we can pull apart something from the dad and the mom to come up with this person. So this person has the disorder, which means that they must have gotten big D, 3 from mom, and then little d, 1 from dad. So now we're going to rate these kids as recombinant or non-recombinant. So this person got a big D, 3, and they're shaded in. So there was no crossover going on. This is right as expected from the dad. So this is going to be non-recombinant. And we can also pull apart from this person, but this is going to be homozygous like this. So they can only give a small d. But in this case, it's going to be written like so. So this person got this from dad, and then the small d4 from mom. And again, it's non-recombinant because no crossover occurred. How about this person? So we see a big D, 3, and it's shaded in, and then a little d, 2. So again, no crossover occurred. Here we have little d, 1 pulled, and then little d 4 as expected. It should be an open circle because they don't have the disorder, because they don't have a capital D, so no crossover occurred, so it's non-recombinant. Here, though, we have this person shaded in, even though we know that a small d corresponding to 1 means that they should not have the disorder, but they do. So what must have happened is that a little crossover occurred, where instead of having a little d1, they have a big D1, like so. And they still have a little d4 from mom. So this person would be recombinant because crossover occurred. So now we're on to this person, and it looks like they got the normal set from both parents because they aren't shaded in, as they are not supposed to be. So this is non-recombinant. And then this person is shaded in, so they got a big D. And then a small d2, so this is non-recombinant. So now we want to count how many we have. So non-recombinant people, we have 1, 2, 3, 4, 5. Then recombinant people, we have 1. So now we can plug into our equation, our phase known equation, and begin to solve. So we have theta to the first, 1 minus theta to the fifth over our total, which is 5 plus 1, which is 6. So now what we can do is plug in different values for theta and then solve for our LOD score. And these are the most common values, so I'm just going to use them. So we have log. I'm going to start with 0.05. So 0.05 to the first, 1 minus 0.05 to the fifth over 0.5 to the sixth. That will give us 0.39. And now just go back and plug in all the rest of the numbers. And I'm just going to let you know what I get. So we got 0.58. So I plugged in all of the theta values, and I got these answers as the LOD score. So now we have to ask ourselves this question. Is the LOD score greater than or equal to 3? No, it's not. So to answer this problem, the answer is no. A disease gene is not linked to the marker because, again, we don't have a LOD score that's greater than or equal to 3. So this is how you would solve this problem right here.